Hello everyone, and welcome to another video of the database on Cedar workshop. For this video we're going to be talking about a few basic commands on MySQL and how to issue small commands, and I'll guide you through a few commands we can do on MySQL. So to start with, let's get into the Cedar console here. Let's look at what is my current version for my client. And this command version is a bit tricky because the 14.14 is actually not the version. You should consider the version as a 5.5.54, which is actually the version that is the current one. But if you do module load, we're going to see that the new version 10.4.11 is going to appear. And in order to, again, I'll do a similar step like in Postgres. I'll make this actually automatically loaded on my home directory, and then I add this to the end of my bash rc file. Then it goes like this. Now next time I'm logging into Cedar, I'll be getting the most recent version called under your home directory called .my.cnf. I'll just take a look and see whether this file is available for me. This file should be installed by Compute Canada once you've requested access to the MariaDB database. Take a look here. .my.cnf is actually available for me too. Okay, we can now use the MySQL client to log into MySQL, and we can do so by typing MySQL. Once you get here, I could do some basic commands. For instance, if I want to list my database, I could say show databases, and all my database will be listed. And you see I already have two databases, and we could do a quick test here. Let's create a new database. I could say create database. At this point, it's quite important that your database needs to start with your Compute Canada ID, and in my case it's alopis and underscore and the name of the database. In this case, I'll simply call DB, but it could be any other name. And database is then created. Once I type quit, I could do Ctrl+C or then type quit. Both commands would work. Let's now load some commands on our database table. We can quickly take a look on our sample files here. So I'm already on the DB workshop / MySQL directory. If you are not, then get into this directory, and let's take a look on the Canada City file and see what it does. So more canadacity.sql. So what it does, it creates a table, and then it loads the canadacity.txt file into this table. So it's basically loading our files in our table, and then it executes a select count to show us how many records has been inserted on our database. And finally, it does show us 5 records, 5 rows on our database as a sample. Let's execute this file quickly and see what it shows us. So in order to execute this file, we then type MySQL-D, uppercase D, and then our database name, which I've created as alopis underscore DB. And then again, I use the operator less than, and we can say canadacity.sql, and that should ingest our data, and as well as show us some samples of our data. Let's see how it works. Great. So exactly as we expect, right? So it inserted the data into our database. It did a count. In terms of records, we have 5,521 records, and then we have 5 samples of the cities of Canada. And this table, if you remember well, it's exactly the same data we inserted to Postgres as well. It's the same data set. Okay, great. So what if we would you like to do more older operations, right? So let's play it out. Let's play with the demo one explain and see how would explain work for MySQL. It's quite similar to what Postgres done, and it's also quite interesting for us to understand how is our queries performing. So yeah, so here's an example where we are selecting city population from Canada, where population is larger than 100,000 inhabitants, and we also are ordering by population. And now we have the explain query down here, which then will tell us what is the cost associated with that query. So we should have two results for this file. Let's see how that goes. Let's execute this query against our database. Again, I can just do MySQL-D, my database name, and then my example. And there we go. We now have our cities ordered here. And what is interesting now, I can see what is our explain command. What is it saying? How many rows have been scanned for this query, which is the most important information here, and what are the filters we have used. We now could actually create an index for this database and see whether the cost associated with our query should be different one. So if you run explain, my expectation is that now the number of rows scanned should be smaller, given that the index would allow us to actually skip some of the records we are not looking for. Let's do that then. So MySQL demo 1, and let's first just take a quick look. How would the explain how would the index creation work? And it's quite simple and very similar to Postgres. So you basically do create an index, give a name for this index, and then you tell MySQL what is the table you'd like to create that index and what is the field, the column you are targeting for that index. In this case, it's population, because population is the column we are using for our select, for our filter in our select query. So that's why we creating an index for that would optimize this query. And let's run this then on our database and see how that goes. So demo 1 index. Okay, index should have been created. If I run again the explain, I would expect I have a smaller number of rows, and there we go. Now it tells us that the IDX1, the index we've just created, has been used, has been selected, and now the number of rows that has been scanned in order to retrieve the results is way smaller than before, which actually makes it more efficient. So this is how we could optimize some queries on our database, and how indexes could help us in order to retrieve faster results. And now I'm just going to run a few commands here, show you basic things we can actually do on our interactive query. Let's if I'm going to show database, I could type this. You see database I've just created, and now if I, for instance, would you like to select a specific database, I could say Lopez_DB. I'm now using the Lopez database, and I could execute queries against that. So if I want to show the tables which are on this database, I could say show tables. That tells us Canada_city, the one we just loaded. If you want to know more about the Canada city table, we could say describe Canada_city. It would tell us what are the columns on this table. And then finally, so if I want to know the number of records on this table, we could say, we could do a select count. typo here, and there we go, number of rows on our query. So again, this is pretty much like Postgres. So explain will not execute the command. So it's a quite handy command to understand how is the effort for the database to process the query you are trying to do. Again, some rule of thumbs on fields, and this will be exactly the same for Postgres. If you have fields that are involved in joins, those are fields that are very good candidates for index creation. Also, order by is another point where indexes would help. And definitely the where clause, as by our example, could be optimized using index too. So if you have fields that are involved on the where clause, those fields are very good candidates to create indexes. And finally, I would also add that as you create an index, it's also important to, again, check the query you've created, the index that you are trying to optimize, and take a look whether that query is actually taking advantage of the index, because this is something that Explain could tell you. This is quite interesting for you to make sure your indexes have been effective against your query. Okay everyone, that's pretty much it for this video. I hope you have enjoyed this video, and I see you in the next video. Bye.